This video is about synthons. Recall the synthesis of alcohols by an ester. Initially, an acetate anion does SN2 to replace the chloride to make an ester. We then hydrolyze this ester to form an alcohol. In essence, we are using an acetate anion to add a hydroxide group onto the molecule. We would say that the acetate anion is a synthetic equivalent of a hydroxide, or a synthon. Other synthons include Phthalimide for the Gabriel synthesis, where it is a synthon of an amide anion, and a beta-keto ester is a synthon of this enolate, whilst this malonate is a synthon of this enolate. Why do these matter? Well, all synthons are alternative routes to make something that you are unable to make directly. For example, say you want to make this ketone from this alkyl halide. You attempt to make an enolate out of an acetone and react it with the alkyl halide, but there is no reaction. You decide to then use the beta-keto ester as a synthon instead, and your reaction works wonderfully. But wait, that's not the product, you handsome intelligent fool, I hear you say. Well, you'll have to see the next video to understand why that is practically our product.